working very nicely, and then you are told this car will come to Kenya in the next 1 year and it will look very new. So you pick the car, then at some stage the bushes don't work, the following day so it doesn't work, but then the good thing with that is that you can easily get the parts to replace. Now, the reason or the lesson we need to learn from the cap that should be Treasury put the Minister of Transportation in terms of the age of the cars is we need to understand what informed that cap for the age of the vehicles coming to the country. Then we now compare with the engineer Njoroge's 80%, which probably is saying he's doing some studies to justify that. I'm also happy I have students doing the same, your workmate, assist her thesis to justify the 80%. But we need to draw lessons so that it should not be arbitrary. You know, the 8 years, I don't know what we base on. Is it 8 years? Yes, 8 years, yes. I don't know what we base on. But then we need to really now know that going forward, because for the EVs, it's a bit emotive in the sense that if the battery fails, then the car's failed. It's not easy for IC engines to fail. It's rare, actually. They do fail but once in a while. But then when the battery fails and we put a cap that the health of the battery health is low, then the car fails, then the car stops to move. And then after a number of years, it's technology diffusion. It gets a bad name, then it doesn't pick from there. So that's one area we need to be very careful with. Then there's the area of course, inspection, which we need to see how the countries of origin have been doing inspection for the second-hand vehicles to see how do we map the benefits that we've been having from there. We map on the on what we're having right now. Do they revamp the vehicles before they come, before they do the inspections? So can we apply the same on EVs? Thank you.
Thank you very much, Engineer. I'll also be one last question to Engineer Joseph before we go, Tunga, before we move to the audience. One of the technical specifications we provide when we are looking for vehicles is gradability. The ability, and we have heard about, especially on the two-wheeler and others, whether these vehicles are able to climb hills, whether they will do the same, they will perform like their counterparts, the ICE. Is there a relationship between the ability, the gradability of an electric vehicle and the best how the battery is managed?
Okay, thank you. I think gradability has to do with the motor, not the battery. So the way the battery, the motor is managed determines if a vehicle will be able to climb an incline of a certain percentage, like let's say a gradability of 100% of that's 45 degrees. It depends on, like for now, if you have a nice vehicle, you usually use a motor to crank the engine. That motor, you can only crank it for only 60 seconds. Anything more than 60 seconds is likely to overheat and it gets damaged. The same happens with the motor which is used to propel an EV. The motor which is used to propel an EV, they are usually managed such that they ensure that before they overheat, the torque which that motor is produced is usually drawn down. So for us to have effective motors for our EVs, they need to be cooled such that they can maintain more than 90% of their torque, of their peak torque. Let's say I think of a scenario where you are moving from, let's say from Baringo to Iten. That road is very inclined. If you have a motor that's governed to maintain a certain low value of torque, it's likely to not to take you up to the hill. So if it's cooled enough, that's why EVs shouldn't be specified within our context to have a liquid cooling. That liquid cooling will assist those motors to be able to maintain their peak torque such that a vehicle will be safe to go through an incline.
Thank you very much, Engineer. To move us forward, I'll go back to Engineer Joroge and ask, within the region, now that we are integrating our market, is there any a coordination between establishment of the e-mobility standards, and what aspects do you think should be harmonized within this the larger region, the bloc?
Thank you, David. So within the region, actually Kenya is leading in terms of most of all the parameters or sectors. In terms of standardization, we are leading. However, in the EAC region, we are yet to actually harmonize our standards. But at the African level, there's an IEC equivalent organization called AFSEC, that's the Africa Electrotechnical Standardization Commission, that is setting up a dedicated project committee to actually try and harmonize standards in the charging space, in the EV space in Africa. So as KEBS, we have nominated experts. We are also part of that project committee to be able to actually harmonize standards in Africa. So in the EAC space, it's unfortunate. It would have been lovely to be able to harmonize EAC standards. We've done that in very many and different sectors in Kenya. The EAC standardization space is quite vibrant. You can imagine Kenya, we are a population of, let's say 55, I think it's 55 million. In terms of market share in the EV space or e-mobility space, we are quite small. We are almost insignificant. If you talk to the companies which actually are players in the market, when they go to source products, it is quite difficult to have a conversation or actually to give suggestions in terms of changing some of the parameters. We know that Kenya, we drive right-hand vehicles. If you go to China and you want to get a supply line to be able to import vehicles from China, and you tell them to switch to right-hand, they'll ask you what is your market share, and they'll realize that it's quite insignificant. However, we have 8 vibrant countries in the EAC region. I think we onboarded DRC, we onboarded Somalia. So right now we are at a population of 302 million. So you can imagine if we have one standard that actually talks about charging infrastructure. If we want to source for products from India, from China, from wherever, that is a market where we can actually have a say. So it's unfortunate, but that's an area where as Kenya, we are going to lead that conversation at the EAC, as we always do. In the East African space, Kenya, I would say we lead a lot of standardization conversation. And that actually brings me to something that I mentioned about the 80% and the 8 years, which my fellow engineer Fenwick's talked about. So the 8-year is not a quality metric. It is just that it was an agreement between the partner states. For us as Kenya, we wanted to go lower to improve quality for Kenyans. However, given that we have to come to an agreement, we settled on 8 years. Now in the EV space, that is not a metric that we can be able to ride on and use, given that an 8-year-old vehicle is quite old. I would say in the e-mobility space, that's a fully it's a really depleted battery, so it's below 80%. How did we come up with the 80%? Studies show that the useful life of EV batteries is from 100 to 80%. Anything below 80%, actually in the curve, you'll have a serious degradation on the quality of the battery. So most countries, that has been the benchmark. What we are trying to do is actually turn that into a technical standard. Thank you.
Thank you very much, Engineer. In 1 minute, maybe you mentioned quite a bit on the timelines. I'll give a number of timelines on the standards you are developing. Maybe you can tell us exactly what is the need of this having a standardized environment? Are there serious benefits for this? So that, as you mentioned, that we found that quite a number of people think that you stifle innovation. What is the other side of this coin?
Yeah, and David, thank you. I've remembered I didn't answer the last part of your question, which was what, in the region, what should we actually look into standardizing? So that I would say interoperability. That would be a really good area where if we standardize, you can be able to drive from here to DRC and charge with no issues. Yeah, and now in terms of the other question, in terms of standards, actually, the need for standards in this sector, actually, sorry, could you just repeat that?
Yes, I asked what is really the importance of having a standardized environment, especially on the charging infrastructure?
Yeah, so the importance of standards, especially in charging. So in all the sectors in e-mobility is quite important. But in charging, the first thing is that as an investor, you'd be rest assured that your investment is safe. You wouldn't want a situation where you install chargers in Kenya, then after some time, the standard or even a regulation comes and actually overturns everything. So the need of standardizing this now is that it can give investors that confidence that whatever standard has been developed by Kenya, once adopted and implemented, your investment is safe against any law that can come into place. Thank you.
Thank you very much, Engineer. Now I will throw this to the audience. Maybe we can ask a question or two to the panelists. Yes, Dr. Ali? Here's the microphone. We'll take a few questions.
Yeah, thank you very much, the panel and the Kenya Power Ministry for organizing this unique, rare, very, very rare forum. At least twice. This is the second one I'm attending. The other one was in Safari Park, the first one. We appreciate. My name is Odhiambo Dawa. I'm a board member, executive member of Kenya Renewable Energy Association based at Strathmore University Energy Research Center. I'm also a teacher at Technical University of Kenya, and I'm a former graduate of Kenya Polytechnic before it became Technical University of Kenya. The ideas which have been expressed is very important. I'm also part of the standard committee under Engineer Njoroge at Kenya Bureau of Standards. So I highly appreciate the work we have done, Njoroge and others. I want to add something to what Njoroge said, the use of standards. Please note that as universities and as colleges, we use standards to develop curriculum. So that's another use for those people who thought standards has no any other use. We accurately go to standard to know what is the latest and how will our young people fit into the market of any product. So product standards assist us in that respect. Now, there's also something which I wanted to comment. We are talking about lithium. I was in Menengai High School where we have introduced Renewable Energy Club, and we are taught table of elements. Lithium is highly dangerous for flames, burning. And I think in Njoroge, I would like to look as if I'm changing from what the committee, National Committee Standard has done, please. But for safety of all of us and future, lithium is dangerous and it's explosive. Probably I would like more information from Dr. Msonye also on that. And in Los Angeles, which they have implemented EVs for a long time, there was fire which was brought about by EV, and people lost their lives. many times. I have that document I can share with anybody who wants, and everybody in YouTube, you must have seen that. So in America, they're trying to upskill their firefighters because the risk of lithium on EVs is too high. Now, on the other side, there's sodium, which is very safe and very cheap. Probably anybody from the panel can say, why is sodium left out? Well, dangerous and probably useless, in quotes. Lithium is being used for EVs. Right now, all EVs in Europe are using sodium, and none of you panelists there is talking about sodium. Is it that? And I learned that in my table of elements in Menengai High School, lithium.
Thank you very much, Doctor. Thank you very much.
Now, very, very briefly, sorry, please. What are we doing, all of you? Our students have nowhere to be attached. What do you do? We leave our students here. Right now, I have my students here. They don't know where to go for EV. Njoroge, can you answer that, please, specifically? Thank you.
Thank you very much. We have another hand there.
Good afternoon. Thank you. John Kavila, Mobius Motors. So I've heard quite a bit about, with regards to testing and qualification, not being done outside before products are brought here. Can you maybe specify what, though, will you do in country? Imagine a scenario where our matatus, public transportation now is all EV. How are you going to be testing these particular products? We know the state of those particular buses and matatus over time. They are, even today with the ICE vehicles, they're always an issue. So this will obviously present a problem in the future. What sort of infrastructure, what sort of thought process in the future are you thinking about to ensure, as we transition to EV vehicles, especially from public and even private users, that ongoing testing and quality assurance of vehicles on the roads is maintained? Thank you.
Thank you very much. I'll take one last question at the back there. For the interest of time, we'll, yep. Okay, let us take both, but please have a minute to.
Okay, thank you so much. Justin Kipchumba, still from Technical University of Kenya. I was following up on the discussion, and this 8% SOH, state of health of the battery, do we have an associated parameter for the state of charge, SOC, for the same battery? And then secondly, we have what is the position of a fuel cell electrical vehicle in this race? As we talk about batteries, where is the position of fuel cell EV? And about interoperability and the East African power pool and the East African community. Are all these voltages standardized from DRC, from Rwanda, Burundi, Uganda, Tanzania, Kenya, Somalia? Our voltages here are 415 volts, 3-phase, 240 single phase, and our frequency is 50 hertz. Is it the same thing on the other side? Thank you so much.
Yes, thank you very much, moderator. My name is Leonard Kahuto, and I'm very, very much interested in this electrical technology. Let me start by possibly correcting my learned professor for renewable energy. In terms of metals, the most reactive metals are in group 1, whereby we have lithium, sodium, potassium, the most reactive. But sodium and lithium is less reactive than sodium because reactivity increases down that group. So comparative to the 3, lithium is a least reactive, but they are all reactive, yes. In terms of reactivity, sodium is more reactive than lithium. So in case of any preference, I'll go for lithium. It's more safer. Yeah. May possibly, the professor, possibly you can recall and do further research in terms of group 1 reactivity. Reactivity of group 1 increases down the group. Now, from lithium, sodium, and potassium, potassium is the most reactive. Now, if you want me to explain why, I can explain to you. You want the clarification?
Thank you for that clarification.
But let me ask the question. I filled this question to Engineer Joroge. In terms of standardization, what is happening now is majority of these EV vehicles, already you know there are so many toys around. Now, initially, we knew the fossil-powered vehicles were susceptible to legal procedures in terms of registrations. Have to take what I may say, you need a driving license, insurance, and all the other NTSA prescribed conditions. But what is happening now here is, because already you've told us there is this throttle whereby the tricycle, which will be peddlers, the conflicting issue here is in terms of standardizations. Is it a bicycle, a motorbike? Because what you know is, for bicycles, we don't require any licensing. Neither do you require any driving license. So what will happen? Because where do you classify them anyway? In terms of legal procedures and all that. Secondly, there are so many toys that are there in the market. Of late, we've seen others that are actually, what I may say, powered by fossil fuels. Yet you don't require any registrations. They just classified as toys. But what is happening is with the very, very many bikes, the very many bikes that you have in the market, others are electrical. Where will they ride? Do you require any registrations? Do you require driving license?
Thank you. Thank you.
So I need some clarification
we are
on
running
that.
out of time. Thank you very much. I will give the panelists a minute to respond to this so that we can be able to move out to the next session. So for a start, we got a number of questions from the floor, and the first one was about lithium versus sodium. I will draw this to the panel. One of the any panelist who is able to address that. We have also talked about the issues of attachment, and this question is was directed to Engineer Joroge. Also, I expect Joroge, as he deals with that, he has also been asked about the toys around. And also the state of charge and the position of fuel cell. I believe this should be hydrogen or something else. Please. Engineer Joroge, maybe you can answer those items. In a minute, no more. We are out of our time.
Okay. In no particular order. I think the one for lithium and sodium, I felt there's a debate, but what I'll just chip in is that Odawa, you know that we are an importing country. We import technology. So depending on how a particular technology, how far it has reached in a particular country, is what we'll import. We hope that there will be proper research in sodium, but as far as my knowledge, lithium has very good density, and the price point as compared to the energy density is good. Then in terms of attachment, that one, of course, you need to visit the website. Odawa, you're a member of our technical committees. That one, I think you have the answer. But we do have attachment opportunities, but I believe right now it's being done by the public service. In terms of in-country testing, what are we doing, in terms of in future, our PSVs, if they're electric, and how the PSV sector is going. So the thing is that we are going to increase capacity, because right now EVs is at the early stage. So in terms of everything that is being done is still at the initial stage. But once we're able to reach critical mass, that is an area where inspection is going to be done and testing. However, I'll say that that's also an NTSA issue. NTSA are mandated to do testing and inspection for vehicles which are on the road. So that ideally won't be ARCEB's mandate. For us will be when you're importing or when you are manufacturing. Then for fuel cell EVs, that is hydrogen in particular. We do have standards for that. However, we do not have any fuel cell vehicle in the country. But once we get there, I think also the infrastructure for hydrogen will require proper standardization because that's a very sensitive area. And also, I believe there's a lot being done by ministry in also the green hydrogen space. So when we tackle hydrogen, we are going to tackle it all at once. Then finally, I think I'm done.
You have done.
Yeah, thank you.
Thank you very much. I will now pose the question to EPRA. We have been asked about how compatible our network within the region. And as you answer that, maybe a question which has been raised a number of times by players is about the EV tariff, which is pegged at 15,000 units. And quite a number of players are going beyond that and reverting back to their own. So maybe you can comment on that as you keep your closing remarks.
Okay, for the grid code, that's for the regional harmonization of our infrastructure, is there is always a code, which I'm sure actually KPS could discuss that very well, transmission code and distribution code, which when you are doing the interchange between one country to another, they have to be harmonized. That goes hand in hand with also what you do for mini grids, that they should have a specified or standardized way of doing things. And actually that answers the question why people when they ask about standards, standards make sure that we get the same product without having chaos in the market. So the same will be achieved when we'll be having power pool in East Africa, so East African power pool, so that we don't have hitches. In Uganda and Tanzania, we exchange power across the border, so that's already in existence. It works very nicely. Then the issue of the tariff, you know, the tariff is between KPLC and the owner of the charging infrastructure. That's the tariff that was approved. So from there, you know, he has to pay his employees, he has to recover his money. So when he charges now the person who's buying from him, he's going to put there his margins. That's why you wouldn't expect KPLC to sell power to the owner of the charging station at 17, then the owner sells you at the same 17 shillings. You know, he'll be going at a loss. And the thing is, we want both supply side and demand side to be in the market. If you can make a profit, you will not be there. Tomorrow we'll have nowhere to charge our vehicles. So there will be a margin, but I want to believe because of market liberalization, those margins will be different. So you'll go to person A, he'll be charging 0.1x, person B 0.15x, person C 0.16x, that way. So that will depend how they attract customers. Thank you.
Thank you very much. And finally, Jamutunga, just a word as we close, and I hand over the podium to others.
Okay, let me comment on some questions which have already been answered. I would like to start with the one from Professor Ondawa on lithium. The challenge mostly with lithium-ion batteries has nothing to do with the lithium itself. The challenge is in the electrolytes used. And there has been a lot of improvement on such. Right now, I think the batteries are becoming more safer. And of course, the technology has to be there. No matter how dangerous it is, what we need is more education on how to handle that technology. Then on fuel cell, I think the biggest challenge is still with the fuel cell vehicles. It has to do with the cost of setting up the infrastructure. Like the cost of electrolyzers, they use very precious material, which makes the cost of the hydrogen produced to be still expensive compared to other energy sources. So I think on what we are doing, I think mechanical and transport division is willing to participate in this conversation as it works hand in hand with KEBS on issues of standardization. It has representation in their committees, and the issue of homologation, like now the technology has been developed. The KEBS is the referee. How do we see that technology is brought safely into our society? That's why mechanical and transport would wish, if there are people willing to partner with it, to set up a technology adoption center. It will be very welcome, and it will go a long step in ensuring that the technology is widely accepted within our society. Thank you.
Thank you very much. Thank you, Dr. Engineer Musonya. Thank you, Engineer Joroge and Engineer Mutunga, for a job well done. And thank you to the audience for listening to us. Thank you very much.
Please, a better hand clap. Thank you, Mugambi, and your team. Now, in the interest of time, we have to move very quickly, settle to our new, the last sessions for the day, which is breakout session 1. And we're going to request for session 1, they remain in this particular room, and it will be moderated by Engineer Eric Ohaga. And this will be, the topic will be on the skills and knowledge transfer and certification. For the other panel, or for the other breakout session, we'll have Catherine Mumbua. It will be on research and development. And that will be just the adjacent room, the next room. So if we can just settle in very quickly, or settle, we can move to our respective places. And then we should be able to close it within
engagements, and I will do so by inviting the moderator of this session, who happens to be Catherine Mumbua. Catherine Mumbua is from Siemens Foundation, who have been supporting the sponsors of this event in the area of research and development. And therefore, allow me to welcome her so that she can take us through. As she comes, we will clap for her until she arrives on the podium. Karibu sana Mumbua. Karibu sana. Continue clapping until she arrives. The stage is yours.
All right. Thank you very much for that amazing introduction, and thank you all for attending this session. My name is Catherine Mumbua of Siemens Foundation, Project Manager for Social Enterprise and Emobility. And just to set the stage, I know we've had a ton of conversations today around what are some of the gains and misses within the space, what are some of the developments that have been happening. We've talked about so many different themes. But here we're here to discuss the latest developments and ongoing research within the e-mobility ecosystem. And I think it's essential to recognize that there is a pivotal role that research and development plays towards driving technological innovation and shaping the future of transportation, specifically e-mobility. And from advancements in battery technology to integration of renewable energy sources, research and development initiatives are clearly at the forefront of transforming the e-mobility landscape. So the panelists that will be with me today as we discuss what are some of these initiatives and technologies that we're discussing and could be potentially beneficial for this space is Dr. Jeremiah Kiplagat, Director, Institute of Energy Studies and Research. Round of applause as they make their way up. Next we have Dr. Winston. Yeah. Okay. Do you mind to share this up? Dr. Winston Ojenge, Lecturer, Technical University of Kenya. If you're here, kindly come up. Thank you. Next on stage, we have Engineer Ignatius Maranga, Quality Engineer, Strathmore University. And last but not least, June Nyakwandi, Chief Operations Officer, Drive Electric. And if you can we have the podium taken down? You could tell us what are some of the available technologies in the e-mobility space?
Thank you, Catherine. Yes, just a quick introduction. My name is Dr. Kiplagat. I'm Director in charge of the Institute of Energy Studies and Research, which is a department of Kenya Power. It's also a TVET institution. We do support in capacity building, research and innovation, look at new upcoming areas, and we support Kenya Power in growth in those areas. So talking about the e-mobility, there are many technologies and many opportunities that are upcoming. And there is a lot of interest, and that is why people are looking at a niche in this field as it grows. And some of the technologies we already seen that has been applied include like battery swapping. This is applicable mainly to the two-wheeler vehicles. This will reduce on downtime and make the services more effective. As we go on, also the pay-as-you-go models. You know, we are planning to we are setting up charging stations which are open to public use, and you want to a site that is convenient to use, and so we must have pay-as-you-go softwares that will enable efficient utilization by many using available platforms like M-Pesa. So those are opportunities which are going to grow. We have also energy storage systems. As this grows, we realize, and we are keen as the Institute to see the impact on the grid as many charging stations are developed. There are always worries whether the grid is strong enough to support, and we see that in future we may need how to stabilize, and there might be room for energy storage, both at the grid level to stabilize, so that when there are many users, it provided resilience on the grid. So we see that. There is something called regenerative braking technologies. It's not, you know, when the electric vehicles, when you are braking or going down the slope, that is used to charge the battery. It supplements the direct charging. So we are going to see growth and development in those technologies and improvement, even in concurrence with the electric vehicles. We are likely to see also local assembly and manufacturing, and we are happy that the government is so keen on this to promote local development. You find that when you import vehicles or these devices, they may not be well suited for our environment, and that's why we need to promote, to encourage local assembly. I remember about 3 or 4 years ago when we were testing the first motorbikes, which were donated by UNEP. These were relatively, when we were venturing into e-mobility space as Kenya Power. So those motorbikes, we realized the range was very short, like 60 kilometers in a day. We needed like 100 kilometers for our meter readers as they go around during the day. We realized they were not robust. You know, they are designed, some of these countries where we import, they have very nice roads. So when it comes here, it becomes challenging in our terrain, our rough roads. So we realized within a short time, those vehicles, those motorbikes were breaking down. But over time now, there have been improvement, and now we're happy the range has increased. They are robust, more strong. So that shows the importance of local assembly, so that we're able to really produce products which are suitable for local use. Among others, solar chargers, we have off-grid, remote areas. There's going to be interest in solar chargers, areas where we don't have grid, or sometimes where we need to integrate grid, you know, at times captive solar. So solar technologies to be integrated for charging. Among others, those are the technology we see. Serious improvement in battery technologies, and this is key in bringing the cost down. There are a lot of research. I think we have been discussing just a while ago on the types of batteries. So this is key in enhancing efficiency, range, and also bringing the cost down of e-vehicles. Let me stop at that point. The list is long, but those are the ones which I can remember for now. Thank you very much.
Thank you, and I think I learned a new one today, which is vehicle to grid. I'm not certain I know about that, but we're learning as we go. Thank you, Dr. Dr. Oganja, maybe you can introduce yourself and then give us a bit of insight on what are some of the ongoing research and development initiatives locally in Kenya, and what are we also seeing internationally, and how can we bridge the gap between that and what we have currently?
Thank you very much, Catherine. My name is Ojenga Winston. I lecture computer science at the Technical University of Kenya, but I also have a background in electrical technology. I also am affiliated to African Center for Technology Studies, which is an intergovernmental think tank that develops policy in the areas of science, technology, and innovation. My approach is more academic, and I know pay as you go is more close to commerce. They're technologies, but they're basically commercial technologies. But I also know that their background underneath them are the more academic technologies, and that's what I'll focus on. If you go through the operational value chain in e-mobility, you probably start with the charging infrastructure. And there is, of course, I know a lot of research that goes on around fast charging, the modern technologies for charging, like fast charging. But that is more global. In Kenya, under charging infrastructure, I know our research activities would be not as principal level as the global one, but at more application level. We want to, for instance, know where to locate charging stations. And that depends on data, which we accumulate locally. We would want to, for instance, study road sections. I know there are tens of thousands of roads within Nairobi alone, but they are short road sections, like 5 kilometers, 2 kilometers. You'd want to code them and know traffic passes each road section in what frequency. Then you expect that the road sections that have frequencies would probably where you want to put your charging location. There are also issues about optimization of supply and demand within the charging station. Data again, I'm talking from my background, I'm talking about technologies, of course, such as AI, IoT, and blockchain. Lots of data would enable you to, again, know which times of the day, which days of the week, seasons of the year, do demand rise for charging, and especially times of the day you don't want to overwhelm your plant, your generator. So what you want to do is to drag customers or clients towards the slimmer periods so that you're able to uniformize the demand. So optimization is extremely important, and still AI would be able to give you that. But now if you're going to the battery, the next stage in that value chain would be the battery technology. Again, the battery technology in terms of the chemistry, the materials that we know is beyond us. We import that. However, what about the health, monitoring the health of the batteries? Don't you want brand A to be able to tell whether brand A is better than brand B? Again, in order to not stick on hearsay, research means it's evidence-based. You collect data from every operator. You know, if you put a sensor on the battery of every motorbike or vehicle, it throws data 24/7 onto your database, and you can analyze and be able to tell that this particular brand of battery, the discharge rate is too fast, etc. Then you know how to profile the various brands. When you come down to the next level, you're talking about the electric powertrain. Now, the motors, or the inverter motor, down to the transmission, we hardly have much to do in terms of research. That is more global. It's more principle level. Then renewable integration into the charging infrastructure. We want to use smart devices to be able to, that we can do, to be able to do that integration, which is seamless. Then there are issues like path optimization. We can do that. We want to know, for instance, Google today, Google Map. If I leave here to go to where I stay, I'll check Google Map and it indicate blue, it will indicate red. Red means don't follow that path. There's too much traffic, and they also probably integrate the distances. However, who then integrates the quality of road? This road might be better quality than this other one. Google doesn't have it. We can put that in the equation so that when we compute, and who tells you where the flood is likely to be depending on weather? If we put that into the algorithm, we'll then be able to identify the right cost at any one time for which path, and be able to then advise appropriately. I'm almost getting finished. There's at another level, there is carbon credit computation. Which algorithms do we use? I know electric vehicles owners, vendors, charging stations are going to start looking to get their carbon credits because they are saving the earth from emissions. How do you calculate how much carbon credit that is accessible to you? We are using models coming from the developed world, but those models are on roads which are very nice. Here we know that our roads are bad. So if you are trying to save us the emission of gasoline-based motorbike, for instance, that goes through rough roads and therefore the emissions are more per kilometer than the one in the global north. Gasoline, which is likely corrupted, so there's more emission per kilometer than that in the global north. And probably level of service of the engine, which is slightly low, so the emissions are more. So all these are things we need to put into the equation and say, if therefore I convert to EV in Kenya, I deserve more carbon credit than the other guy in the global north. So we are trying, therefore, to develop these kind of algorithms. Then, of course, there is customer behavior, which our marketing departments and psychology departments can do well. And maybe lastly, policy and ethics. Well, thank you.
All right, thank you very much. Ms. Nyandwaki, Dr. Jenge has touched on a couple of barriers and challenges within the space and in terms of even the developments that he sees ongoing. You're in the private sector. What are some of these opportunities and barriers that you foresee, especially around research and development initiatives? What are your users saying? What are you seeing internally in your company? Where do those technology initiatives come from and how do they rise?
Thank you, Catherine. My name is June Nyandwaki from Drive Electric, which is also called Lights and Apps as the parent name. We deal with solar and also Drive Electric, e-mobility four-wheelers, and charging infrastructure at large. Some of the opportunities that I see, and also the company has vested into, number one, is that there's a technology improvement. From time to time, we've seen charging infrastructure changing. We started with slow chargers, which we call AC. We have now gone to DC chargers, which are charging fast, creating good business models, because nobody wants to stay in a charging station for more than, say, 10 minutes, 30 minutes, in as much as we've not reached the 10 minutes yard already. Another part is once you use your vehicle and your battery runs out, what do you do next? Are you supposed to repair your battery? What else can you do with that battery component that we have? So currently we have a yard and a team of technicians who are doing battery repairs, and some have managed to improve some of the SOHs that have gone back into the road. And also we have repurposed some batteries and used for storage in solarization project. I can refer one at Kikambala in Mombasa. It's currently doing very well. So we appreciate and we're still moving into the technology of repair and diagnostics and continuously ensuring that the batteries meet the specification. Another part is there's knowledge gap and it's improving from time to time. So we keep on sending our staff outside the country to at least give us first-hand knowledge. So far we've trained two. We took them to Spain and they were able to come back with a seed control technology that we are currently showcasing outside there in our booth. So we've been able to install several DC fast chargers, inclusion of the one that was launched by not Drive Electric, but KPLC. Yes. So maintenance also tracking to ensure that it meets the requirements is continuous business that we do as Nights and Apps. Another part that has made us really venture into this business is on the cost saving in terms of the operation. The capital expenditure for EVs is quite high, and it makes many people not want to go into EV. But now, after you've acquired your EV, there's what you call the operation expenses in terms of what is your fuel cost and what is the expenditure on the electricity. And from the last data we had last week when you're doing a summary in office, it was 4 shillings when you're doing 4 shillings per kilometer when you're doing electricity, and then 16 shillings per kilometer when you're doing fuel. Another part is that all strategies that we do, we continuously align them with the national standards and commitments that we make. So as a country, I understand we made a commitment in 2020 at the UNFCCC meeting that we are supposed to abate our emissions by 32% by 2030. So what are we doing? So the fact that our technology or rather solutions align with this, it's also a motivation to ensure that we are continuously moving into this space. Some of the barriers that we have is limitation in the charging infrastructure. In as much as we have 28 charging stations, 20 in which are operational at the moment, we still need more. Now, we've installed this for our business case and also for those clients who we've sold vehicles at different areas within Nairobi. But still, there is a challenge because once, let's say, for example, a driver gets a trip that is outside Nairobi, so what comfort do they have to proceed with the EV vehicle? So that limitation of not having this infrastructure outside Nairobi is an issue. So in as much as you give somebody a portable charger that they can use at home, during the day you really do not want to go back home. You just want to be comfortable where the trip is meeting you and where else you need to go. So those are some of the barriers and opportunities we've seen and we've tapped into. Thank you.
Thank you very much, Ms. Nyandwaki. We'll circle back to some of the things that we mentioned later on in conversation. But now over to you, Engineer Maranga. As a quality engineer, what are some of the key considerations and challenges that are ensuring reliability and safety of e-mobility? I know you've touched on quality standards and some of the different standards that have been set, but are there any others that things that people need to know? And what would you advocate for a better future for e-mobility?
Thank you, Kate.
Yes.
So my name is Ignatius Maranga. I am a researcher and engineer at Strathmore University, the Energy Research Center. I am also a member of the e-mobility task force that was gazetted in 4th of August 2023, and our term ends in May. So to answer your question, some of the items that could be looked at to improve quality of electric vehicles, other than standards. First is coming up with a regulatory environment, and of course standards coming here, and as well as policies which dictate and inform, okay, not dictate rather, but which guide on the best practices that we could apply locally. So usually we look at what is happening internationally and customize it to what we have locally. Then other things to look at is, for example, the infrastructure, which has been talked about a lot. So having adequate and a number of charging infrastructure. So one of the things we've been discussing throughout the conference since the morning, and has been talked about by some of the panelists here, is the importance of mapping out and knowing what are the best points to put up charging infrastructure. Of course, the utility and Kenya Power would mention areas where transformers are heavily loaded and in different locations, and what kind of infrastructure needs to be improved. So as Dr. Ojenge mentioned, one of the things to look at is, of course, the traffic flows, which is some work we did with GIZ, and of course looking at the electricity availability and the transformer loading in these places. So you have to match these two parameters and get optimal locations. Then that will guide investors and guys would like to invest in these technologies, and also those who would like to buy electric vehicles in their estates and wherever, to get to know whether these places are ideal, and if not, then what could be done, right? So information. Then, of course, the other important bit also is having worked in, working in a university, is awareness. Last week we were doing a public participation, carrying out public participation for the policy. And one of the things that came out mostly in the different regions we visited was awareness and having guys at the grassroots levels getting to know the importance of electric vehicles and e-mobility at large. How will they benefit them? Where will they get it from? And all other information related to this. So that as well could help create awareness then, of course, when you're talking about quality and safety, if people are aware about these technologies, then the next step is, I know electric vehicles exist. Perhaps this doesn't work well, this works well. How do I get to know that this works best? I like the star rating that EPRA usually has on minimum energy performance standards, where you can tell a fridge that has 1 star is not as efficient as one that has 4 or 5 stars. I was also sharing with one of my colleagues earlier that one other awareness campaign which I found worked really well was regarding compact fluorescent bulbs that Kenya Power was issuing many years ago. And guys, to date, I use the example of my mother. She will say, she wants an energy-saving bulb, and I mean, after going to uni, I knew it's called a compact fluorescent bulb. And now I will tell her it's a CFL, but she will say, we want to get a bulb, look for an energy-saving bulb. I want the energy saver. I mean, I felt that, now when she goes to the shop and many other people, they will know, I don't want to get an incandescent bulb because it consumes more, and I will go for a CFL bulb. So what am I getting at? When you create this awareness, then people will be able to know what is the best technology, what works for them best. Hence, you can get quality in these places. Thank you.
All right, thank you very much. Dr. Kiplagat, how do you see these technologies evolving in the next 5 to 10 years, and what implications might that have for this space, and especially the adoption of e-mobility in Kenya?
Thank you, Catherine. I think in the next 5 to 10 years, driven by a lot of research and development that is going on, we are likely to see lower cost reductions in electric vehicles, which are currently still expensive. And for our market, which are price sensitive, this will be good news because there's going to grow growth in adoption of electric vehicles. So there is research. We talked about battery technologies, how to reduce, increase the length of that the vehicles can move. So that is one of the things. So actually, because of the focus that is in it, really we are going to see a trajectory in growth, and that we should be prepared to really support this. And one of the other areas we are likely to see enabling policies by government. We have seen a lot of commitments. Now the Igniters is in the team developing the policy for e-mobility. And we are likely to see other incentives that government is going to put because of the benefits that are so obvious in electric e-mobility. So we are likely to see really enabling policies and government regulations going forward, which are going to spur the growth of e-mobility. With reduction also in cost, also CapEx, we understand that electric vehicles are lower CapEx in terms of maintaining. So again, this is going to drive this growth. Expansion of charging infrastructure, this is going to happen, and we are happy with the interest that is in the sector. So we are likely to see a lot of charging infrastructure along the highways, major highways, figuratively modeling on petrol stations. That's exactly what we need to do to replicate for charging stations. So highways, wherever there are spaces, we're likely to see a lot of those developing. I think now the buses, what has picked and is driving now is public transport that is the buses. That we are likely to see also a lot of conversion in public transport to e-mobility because of the benefits, where those people who are in direct business who are going to benefit. Perhaps also government might also push for conversion so that government institutions convert to electric as a driver to drive this growth in the sector. And if there are any support in terms of, you mentioned about carbon and other financing to spur that, I think that will be very much welcomed. The other driver which is going to, as I think we have mentioned and there have been declaration to, we are now over 90% green, and there are efforts to move to 100%. This is likely to be a driver to attract a lot of interest globally in Kenya. And so, because it will demonstrate really green and real benefits of e-mobility. So there is going to be now serious relook on investments on green energy power generation technologies and green stability. Basically, those are what I see in the trends in the next 5 years, but there is excitement, which is really good, and everybody sees this as a future, even as hydrogen might come later, but it is, we are seeing e-mobility as a future for now of transportation. Thank you.
Thank you very much. And you mentioned something around climate financing. So maybe I'd direct this to you, Ms. Nyakwandi. How important is research financing and collaborations between different regions towards driving this technological innovation, market growth as well for e-mobility? And what role can an organization like yours play in facilitating such a collaboration? First, let's touch on how important research financing is.
Okay, thank you. Research financing actually is the backbone of e-mobility. And in as much, I like to give let's say a story. In 2016, when my team leader came up with a vision of e-mobility and decided to come in with, to bring in the first vehicle, he wasn't funded. It was based on profits, for example, because he saw the vision. Currently, we are doing several other things in the company in terms of battery research, repurposing, and all around that, which is research still. We are looking for funds to do that, but still it's not readily available. So my call will be, we need collaboration between the academia, then there's the industry, and then the government. For example, if the government can provide grants, can provide, let's say, scholarships for this research, because we're all looking at a common end goal so that people can be trained specifically. They can also set some specific targeted research centers whereby we are advocating for tests on solutions, ensuring safety for everyone. So as industry, we come in to bring in maybe the expertise that we have. But again, this expertise, we have to collaborate with the academia so that in as much as we are training and telling them this is what the industry wants, they're able to tailor-make in the syllabus or the curriculum they're handling. So financing, research financing is very key. We need it. We need the funds. We call upon everybody who's in those sectors to support. Collaborative partnerships between now the industry, academia is essential, because when you're saying you're preparing a talent for the industry, it has to match up to what the industry is doing. So there is no point for somebody to maybe sit in a university in an engineering course for 5 years, and then you come back into the industry and you're not able to really apply with ease. What is happening currently, I stand to be corrected, is that we've transferred the first 2 years of employment of the industry to be a training center. And once somebody has gained a certain concept, they're poached, for example, which is very painful. But again, that is not the role of the industry. The industry needs to have people who are actually ready to come and give advice even as you gain more insights in the industry. Another part will say maybe what role we can play. Number one, we are very open to provide attachments and internships to people who come in and want to know more about this technology. So we've done collaborations with the TVET on the dual curriculum, whereby you are trained, let's say 3 months in institution and then 3 months in the industry, to ensure that at the end of the 2-year session, or rather 3, depending on how long the course is, somebody is well versed. We've also made recommendations to several universities also who have had internships and attachments with us, in that maybe somehow if they can structure their opportunities for attachment to be, let's say, the last part somebody gets when they go into the industry. For example, you take your, let's say if it's a 4-year course, you finish, and then you just do your attachment as you proceed, as you wait for your graduation. It's easier for somebody to be absorbed, because also we've had an issue in that you're training somebody, you think they have understood, but they're going back to school. So again, you have to find another soul to train. So we really need to collaborate. I know there's another hierarchy in terms of changing curriculum and everything in terms of universities and TVET, but this is a call for the industry from my perspective. Another part we can also participate as a company is that we have relevant data. For example, since 2016, we've had several data on the operations of the EV, and those people who have been pioneering the mobility department in our company have been participating in conferences, seminars, and maybe even in some policies formation when they're invited, and they always give our perspective, what has worked, what has not worked. So those are some of the roles we've been playing as a company. Thank you.
Great, thank you. It's a good thing we have representation from academia here, so I'll just throw it back to them. Starting with you, Dr. Ojenge. How do you envision the role of academia in driving innovation and technological advancement in e-mobility, especially considering what Ms. June has shared? What would that collaboration look like, and what part can you play in that?
Thank you very much. I've been wondering, sitting here, where June has been all our lives, because what they're doing, what she's saying is, every word is just on target. It is true. You know, research is the source of everything we do. It's very important that we are involved in research, even as we import and learn and be fluent with these foreign technologies as engineers in industry, but we also need to understand them from principle point of view so that we can add value. What, of course, academia does is we intern our students, and sometimes we would also like to intern our staff much more than we are able to do currently with industry like June's entity, so that then they can take their research thinking there, and when the two get together, skills and research, then it's usually very, very explosive. They can innovate. We are also involved. Currently, I know that Technical University of Kenya, within the School of Electronics Engineering, have spin-off startups. Whether the university is aware that they actually have spin-off startups, that's another question. But these are young youth who have gone through the university, have had ideas that are innovative, obtained from the course they did, And I've gone out here and are now currently managing startups. And what they're doing is extremely exciting. Of course, the university can do more to support them. One particular startup is involved in having EV motorbikes with lady riders making deliveries. But now they've also put IoT into every motorbike that throws data to a central database about distances, health of battery. It's very exciting. But now they want to get into carbon credit market. So the universities can innovate and then can tweak these technologies that we import into customizable for our context and add more value for us. And in time, that's where India started, that's where China started, by adding small values to what was coming from the global north. And now look at how big their industries are. So that's what we need to start. We import their technologies, we add value based on our data, our context, and then in time, the industries mature, and we are able to actually influence the industry more.
All right, great. Thank you so much. I hope June and the doctor here will have future engagements to elaborate further on this. Back to you, Dr. Kiplagat. In what ways is your institute involved in research and development within the e-mobility ecosystem? And what are some of the notable advancements and projects that you're currently working on?
Thank you. The institute, what we are